making them relative. Look like the files that I did open up, looks like everyone got the idea down and kind of expanded on it a little bit. Okay. They looked right.
Like on mine, I simplified my points because I had like 13 originally, and I ended up with, I think like 7 or something, but I ended up with what looked like 2 curves. So each curve had like 2 points instead of 1 midpoint. Was that okay? Like like Kristen kind of figured out how to do it and stuff, so I went with that.
Yeah, you can definitely simplify it.
But it's okay that instead of like each curve having 3 points, I had 4 points.
Oh, yeah.
I had a start point and point and 2.
Yeah, that's fine.
Yeah,
Yeah,
like
it's just, obviously
so.
with more points, you have more parameters
Yeah.
that you have to enter in, but that's fine.
I just want to make sure it didn't need to be 3 points, because I know when we had talked, we said like maybe using an arc to get them, and I was getting crazy complicated.
Yeah, it still has to be the spline through points. The arcs don't work, snapping to the points. So it's always the spline. So yeah, that'll work.
Kate has it.
Sure, that's where I'm going. What is your fiance come out from Germany? Has she really? Oh, was she just last semester?
Yeah, it was only 8 weeks.
I feel like it's the same semester. Sorry. Well, glad to have her back.
Yes, I am.
Oh, I need a number. I'm going to be a little older.
Yeah, but
I was trying to be nice, and she interested in Patrick's life. God. I haven't been involved in his life in like 2 years. Sorry, I don't remember what goes on. Didn't even know when he gave every time walked by and heard him talk.
Okay, for those of you that just got here, on the resources download page, basically I need you to download the RFA file under Class 15 Bridge Tutorial Part 2. And then go ahead and open it up, yes. No kind of settings down here. Does anyone know how to turn off the brightness on these monitors?
I do.
There you go.
It's so annoying.
Yeah.
Oh, you changed them?
You want to tell everybody?
I mean,
very hard.
It's not easy.
Hit too hard, goes black forever. Oh, that's bad.
What?
Okay, let's
I do that.
I'll give you guys a minute. The file that you download should be called Bridge Tutorial Family File Bridge Path Version 1. And go ahead and open that up. Good? Alright.
Probably going to need any of the ones we did for our own pets.
you're off the video or like, so bad.
Alright, let's go ahead and get started. Basically, we're going to continue where we left off. This file that I have loaded up here, I actually added a couple more parameters for what we're going to be using today. And also, if you remember, I sent you guys an email on, I think it was Saturday. And I also had a PDF that we're going to explore a little bit to have a refresher on trigonometry. You guys thought you were done with math and you never have to use it again. Not the case. All right. Let's see if this works. So right now you should have your point file open, and basically we can change the bridge length, right now it's set to 1,643 8 inches. You know, you can change it to a larger dimension, and your points should adapt. And where we left off last time, all we got to was basically dealing with the scaling of the x values. So everything was relative to that start point, and so basically your bridge could stretch no matter what dimension that you wanted. One thing, so that we can get the y dimension to also scale, is that we can take all of our y dimensions. So right now, I've got a curve 2, those midpoint y's, the my, and then the curve 1 my. We can actually give that a formula, and some of you already figured that out based on some of your homework assignments I saw, that we could also scale that based on the curve length. So on the curve 1 my parameter, we're also going to scale that with the curve 1 overall length. And so we don't have to do the math here, I've already got it. It'll be times 0.182. Oops. The way that I got that is I took the number that was already assigned to our curve 1 my, and I just came up with a ratio just like you did with the x over the overall length of the curve 1. So we're doing the same thing with curve 2 my. Essentially, if I had a calculator, which I'll pop up here for a second. Basically, all I'm doing is for the curve 2 my is set to 170 feet 7 inches. So the way I'm getting these values is I'm typing in my 170.58 divided by the overall length, which was curve 2 length, where are you? There it is. 1,314. So 0.129. It's not quite what I had here. Oh well. Just go ahead and type in curve 2 length times, I actually had 0.158. So it doesn't matter, it works. Oh, I see, because I changed my overall bridge length. That's fine.
So what is it? What are we multiplying by? 0.1.
I'm doing a curve 2 length times 0.158. The reason I got a different number is when I did this originally, I've already changed my bridge length to 2,000 feet, and so that changed all of my overall lengths of everything else. But these are the values that I had based on the 1,643, the original length. And then the last one is the curve 1 EY down at the bottom here. This will be bridge length. I'm just going to do 0.007. And basically all that is doing is continuing where we left off last time, so that whenever we scale the overall length, so if I type in 3,000 feet, everything is proportionate to one another, and these y dimensions change based on the overall length of the curve as well. Now before we continue on, remember I told you guys not to actually put in a spline connecting your points yet. It's best, and basically the reason we're spending so much time on this path is that everything is going to be relative to this path and build off of it. So we want to make sure that all of these points are set up correctly. And the last thing that we have to do is set up the z values of all of these points. And remember, our bridge could actually slope from one point to the other. And the points in between will also have to adapt to follow a consistent slope. So first of all, what I want to do is we've got our start point and our end point. Those will be pretty easy to figure out because we've got back in our properties, we have a bridge spot elevation start, and then we have our bridge spot elevation end. The curve 1 SZ, the S stands for start, and the Z point, that's going to equal the bridge spot elevation start. So I'm just going to go up here and Control C, copy that entire verbiage, bridge spot elevation start, and I'm going to come down here to the curve 1 SZ and put that in the formula section, Control V. The next one will be the bridge spot elevation end. Go ahead and Control C over that text. And if we go to the curve 2 easy, that will be the end point elevation. So what we can do is in our start, in our parameters under bridge spot elevation start, I'm going to type in, let's just do 641 feet. And our bridge end, let's just do at 650 for now. Once we do that and you exit out of there or hit apply, you should see both of those dots move up. So obviously when we eventually bring this into our Revit project, when you enter in the spot elevations that you read from the topography, that will automatically set those 2 points to the correct elevation. So everybody might want to hit save since we got some things working. Now, how many of you all remember how to find the slope angle if we only know a couple different parameters, within trigonometry? If we happen to know the adjacent of a triangle and the opposite leg, we should be able to find, with a formula, the actual angle of the slope. And right now in Revit, what we have is, in our parameters, we know what the bridge end is going to be, what the bridge start is going to be. So what we need to find out, we also know the bridge length. What we need to find out is the overall height, or the bridge total rise. So down, if you look under analysis results, I've already typed in a parameter called bridge total rise. This will just be the bridge spot elevation end, so I'm going to Control C over that, put that in the formula, minus the start. And that'll give you the bridge total rise.
Is there any way to make your
So this is under analysis results and bridge total rise. The formula, you basically need to find out what the difference is between the top and the bottom of the bridge to find that total rise in the slope. Everyone see that okay? The easiest thing to do is always just highlight the text and Control C and Control V. That helps. So basically what we know is we know the overall length of the bridge. So we've got our bridge length, and right now I have mine set to 3,000 feet. It really doesn't matter what you have it set to. The other is we just now have a formula that has figured out the total rise in the Z direction, overall the entire length of the bridge. So I went into a very long explanation here on this PDF, just in case you wanted a refresher on trigonometry. But all we really need to know is that we can find any slope of an angle if we know the opposite leg and we know the adjacent. So the adjacent is the overall length. The opposite is the overall total rise. And if we use in the formula section, A tan, which stands for arctangent or inverse tangent, that gives you the degrees of the opposite over adjacent. I go into, if you want to read more on actually how to do that without using the arctangent formula, you can go ahead and do that by hand. But just to make things easy, if we go into analysis results, in the parameters, I have a parameter there set to slope angle. So what we want to do is type in A tan in parentheses. We want the bridge total rise, which is the opposite, divided by the bridge length. And so that will give you automatically a slope angle. And I'll explain why we need this formula. Does everyone have that entered in? So I can zoom back out here? All right. I'm going to hit OK, just so that if I ever have to undo anything, I can undo. Now, the next part is we want to know what each of these different points are in between the start and the end, what those are going to be along the total length and what height those need to be set at. So the other part of this formula is if we know the angle, which we just now figured out, we can now find any z length as long as we know the other x length by this other formula down here, which would be basically the slope angle times x. So, best way to find this out is if we go into level 1, where we can see all of our different dimensions here. Let's go to this first point, which should be your curve 1M, which is kind of, it doesn't line up with our drawing anymore. But we know the overall length, curve 1mx, we have that already in a formula. So the z of curve 1 mz will be equal to curve 1 mx, which is basically the length. And if we multiply that by the slope angle, inconsistent units before. Oh, sorry. We need the tangent. Tangent of the slope angle. We're kind of doing that formula in reverse. Times the curve 1 mx. basically doing that whole calculation in reverse because we know the angle, we know the overall length, but we didn't know the height. So right there is tan, T-A-N, in parentheses put slope angle, and then times curve 1 underscore mx.
Let's say tangent slope angle.
Curve 1 and that's
What's that?
curve 1 and that's basically like.
Yeah, it's basically the overall length of where that point is located, and then we want to know how high it needs to go to meet up with that angle. And so that's the form. Did you get it?
Yeah.
Okay. Everyone get that to work out without any kind of errors like inconsistent units or anything? The last thing that we need to do on that formula is put all this in parentheses, and we want that added to wherever the curve 1 start point z location was. Remember, the start point is going to be moving up and down, and so this has to be relative to wherever that point ends up moving to. Basically, this is going to be as hard as all these formulas get. Once we get this set up, you'll be ready to go on any of your bridges. So you got that formula? Go ahead and take that whole formula and Control C, select it all and hit Control C, because you're going to need it again. And zoom back out. Hit OK. I'm going to look at my 3D view, and you should see that that point moved up, and it looks like it's moving up on a consistent slope very gradually. So the next point is this one that's in the middle, and that one is using an overall length of curve 1 EX. So since we already have the formula down, if we go to, this is curve 1 EZ, zoom in. I'm going to Control V into that section. So curve 1 EZ. This one is the tangent slope, but instead of curve 1 MX like we already had copied, change that to EX. So if we look in our 3D view, we double check it one more time, and we should have that point sloping or set. Now this next point, the very last one, is going to have an additional parameter to add in, because if you remember, this point is relative to this other dimension. If we look at the dimension string, it's not coming all the way from the 0 plane. So we've got a curve 2 MX, and the overall length is going to be the curve 2 MX plus the curve 1 EX. So we're just kind of adding on to this dimension a little bit. If we go to curve 2 MZ, and you should still be able to hit Control V. At this part of the formula, if we just put in a parentheses after the multiplication sign, after tangent slope angle, so we got curve 1 MX. We want that to change to EX. And then we'll add in curve 2 mx, and another parentheses. Does everyone understand that? We basically had to add those two lengths together so that we got that overall length of wherever that point was ending up. Okay. And so it looks like our points are sloping from the start point down to the end point.
I missed the very end of that last parameter.
It's tangent, slope angle times, and curve 1 EX plus curve 2 MX. We got two parentheses to close that out, and then we still need to add it to curve 1 SZ.
Make your end elevation like 1,000 feet.
1,000 feet?
Or, yeah, just so my future to see that. So, do mine shoots too high?
I'll make this like, did mine at 0 and 1,000. So you should have a very consistent slope. Let's see, which one's not looking right? It's like the end point? Well, the end point should just be equal to, so if you go to curve 2 EZ, right there, goes to that elevation. When you figured out the angle, you want this to be of the bridge length. Because you want to figure out the overall length of the bridge and then the overall height to get the angle. That's why. So if you test out a very extreme condition, put like 0 for the start and then also 1,000 for the end, you should see a very consistent slope. And if we switch that around, we also want to test that this could also go negative. Yeah, it's a pretty steep slope there. You could probably make it go straight up if you wanted to. And so even though our bridge is kind of like an S curve, you know, this overall length and the slope will be fairly consistent all the way from start to end, but it's not going to be precise because, you know, we're not actually figuring out the exact location of the S curve, but it should give you a pretty consistent slope, at least for design purposes. So that basically now what we've done is we have made all of these points adjust in basically by just changing the length. It scales and also changes the consistent slope all the way from the z's. So we got our z's, our y's, and our x's completely scaling appropriately to conform to whatever our constraints are up here at the top. So once we have all that set up, we can now start to model the bridge, finally. I told you at the beginning that this takes a little bit of pre-planning and some programming ahead of time. But since everything is going to be relative to how this bridge grows, and or you could come in here at any time and change any of these Y parameters and change, you know, your bridge could go from a S shape to a very extreme curve, or, you know, could almost straighten out if you try to take everything down to 0. You should be able to play with those parameters, but right now we're just basically scaling that S up and down based on that length. So now that we've done that, we can select all of these points. I might want to hit save. We can select all of these points, and then we can use the spline through points command. But when we do that, it's going to create a model line spline. We actually want that to be a reference line. If you guys ever make, basically what we're going to be doing is making a cross section of the bridge and then sweeping it along this curve. If this remains a model line and you sweep any kind of shape along the model line, anytime you adjust your parameters, you're going to get a little favorite dialog box that pops up that says constraints not satisfied. Very annoying. And if you change this to reference line, all of a sudden you don't get that problem. So if you see yourself always getting that constraints not satisfied after you've done all of these steps, really make sure to check that we're changing this to a reference line. The way to do that is click on the line, and off to the left in the properties, there's a, under identity data, let me expand this out. It says is reference line, and it's unchecked. Just go ahead and check it, and it should turn purple, and now it's a actual reference line. Under your family types, under the dialog box, when you look at your parameters again, you should also notice I have under constraints, there's a bridge width, a bridge depth, and then down under analysis results, I have a bridge width half as well. Let's go ahead and also add in, under constraints, a bridge width. And I did an underscore and just a number 2. It's just a type. And then we also need to create another one under analysis results. And I'm going to call this one bridge width underscore number 2 and then half. In order for if you look under analysis results after you hit OK, and we've got the bridge width half and our bridge width 2 half, in the formula you basically need to take whichever bridge width it's referencing and divide it by 2 in order to get your half dimensions. Right there. The actual constraint is it's up here under constraints, bridge width and bridge width 2. All right. Under bridge width, let's just type in 50 feet. And under bridge width 2, we can go ahead and we'll also type in 50 feet for now. So once you do that, if you go down and check your formulas or analysis results, obviously your halves should be at 25 feet apiece. And under bridge depth, let's just type in 10 feet for now. Everybody's been wanting to know how to get some depth to a lot of your paths. Most of you that have made your path or had an attempt at making your path so far, most of you made a rail that's basically this curve on either side, and then you lofted it together. Once you do that, you only make a planar surface and you cannot extrude it. And so what we're going to do is use this rail as a centerpiece or a center point or a center spline that we will put a section profile on top of and then sweep it across the whole entire path. To do that, once we've got all these points set up, we can now start adding another point element, and we can host it on the reference line. Because this is now a reference line, just pick anywhere on the line, it really doesn't matter. And then once you snap it onto the line, go ahead and show the reference planes to always. This way we can see that perpendicular reference plane. And now we're going to draw lines. When you click on line, and I think we want this to be, let's do it as reference lines. So click on line, reference line, and then also make sure 3D snapping is off.
My reference grid didn't turn on whenever I hit show.
Sometimes you actually, the actual grid, when you turned it on to always, it didn't show up. If you kind of rotate around and or switch views, like go into level 1 and then come back into your 3D view, it might show back up. I've noticed it's kind of a graphic card issue. Is it there now? Nope.
It's set to always.
Yeah, it disappears from time to time. Don't worry about it too much, we can still access it. So if we got your point set, we're going to draw a line and make it a reference line. Also make sure 3D snapping is off, and snap to the center point. Oh wait, missed a step. Change your placement plane to pick, and we need to pick that plane that's perpendicular to the line associated with that point. Then we can draw our reference lines. And I'm just going to draw, and you should notice because we have 3D snapping off, that when you start to draw and you get close to orthogonal, close to 90 degrees, you get a blue dotted line that it snaps to. Well, you want to make sure that you're drawing at the 90-degree mark. I'm just going to draw some length off to the side, some length down.
We're snapping to the center of that dot.
Yeah, make sure you snap to the point. And then I'm coming across, and I'm going up. And I'm not going to close the shape. I'll keep it like this for now. We also might want to turn on our thin lines in case you have some really thick lines. And the last part to close this shape is if you go under Modify, there's the Trim and Extend to Corner command. Click on that, and you're going to select one of the lines and then the other to trim and extend to the corner and basically close this shape. If you drew this with model lines, just click on all of your lines and change them to reference. I think we want reference.
I want to select all of that.
And then we're going to start striking a few dimensions. So using the dimension tool, I'm going to dimension from the outside vertical line to the vertical line of this reference plane. So you want to make sure you're snapping to that vertical line. And I'm going to do the same thing to the other side. And then the one that's on the bottom, the horizontal dimension, or the depth, I'm going to go from that bottom line to the horizontal line of that reference plane. If your reference plane doesn't show up, you should still be able to hover close to it and you'll see a blue line that pops up. You may have to zoom in. And you should, make sure that when you're looking at your bridge, when you rotate around, you're looking at this center spline, that your larger dimensions are on the horizontal, because it really doesn't matter at the moment. All right, does everyone have your dimensions? You guys are going to have to get good at dimensioning. Everything is dimensioned in Revit, and then when you have to do your construction documents, you have to dimension like crazy.
Can I dimension to the point?
When you do this, did you take that reference point?
Well, I guess it's wow. Straight diagonal.
I kept trying to.
I think you need to keep it down. But you can't find it?
Dang, I don't know how many degrees.
I started snapping when I wrote last week. This one is snapped on the first. Yeah.
So you may not have selected that plane, and that's why it wasn't allowing you to snap to it. If you're having trouble with your dimensions and you can't get it to snap to the reference plane, you probably need to redraw that section profile and make sure that you draw it by picking that reference plane to draw onto. Otherwise, you're not going to be able to snap to it.
I think mine is in
Yeah, I think yours is vertical. You need to rotate yours. You may need to draw it over. Okay, once we have those dimensions, the dimensions that is on either side of the point, if you select both of them, we're going to make those equal to the bridge width half. And this other dimension is bridge depth. Basically, those parameters are making it so that your bridge, no matter what the width is, this profile will always be equal on either side of this spline. So now you should be able to select both your reference spline and this section profile and select create form. So once you have all that established, select the spline, hit the control key, and then also select your profile that you just created, and then select create solid form.
Select the
Make sure those are reference lines. Click on that, say it is reference line.
and then the spline also.
So you should be able to test your bridge now by typing in different lengths. So maybe I'll type in 1,000 feet. I should be able to change my angle. So my start is at 0. Maybe I'll just go up to 100 feet for now. And your shape should be conforming to all of these different changes without any errors. The next thing is if you change your bridge width, let's change it to something like 100 feet. Remember, we always have this issue where it doesn't grow consistently along the whole entire path. It's basically only adjusting wherever we drew that section profile. So does everyone have something that looks like this? A little boomerang? So to solve this problem, all we have to do is select the whole entire solid and click Edit Profile. And then select one of the ends, and you'll go into a sketch mode that shows you a section profile at the end. Now we can add dimensions from the corner to that center line, this other side to the center line, just like we did before. And make sure you're snapping to those dotted reference lines. And you can set these parameters to be the same thing. Bridge width half and bridge depth. When you're done, click on Modify, and you should see the basically the Finish Edit Mode checkbox. And then we have to go over to the other end and do the same thing. So I'm selecting the whole entire mass again, clicking Edit Profile, and then selecting that edge.
Getting an error whenever we try to hit, like, finish that. So bridge width half, and bridge depth, right? Screws up those two.
You have to make sure you're snapping to the dotted reference line.
That's what it is.
So I'm striking a dimension from the edge of the section profile, and I'm making sure to snap to that dashed line in the middle. Same thing with the depth. There is a horizontal dashed line there. You may have to tab. And again, that's bridge width half and bridge depth.
It still says
You know why you wouldn't be able to select the end phase?
But you're adding a profile. So you need to click on the solid and hit say edit profile, and then you can select it. You guys have rotated crosshairs? Anyone else have a rotated crosshair at the end?
Yeah.
you guys may have, when you drew your section profile, was it exactly 90? And I did that one, so I might have messed you up there somehow.
It looks like it's really fun.
Yeah. See if you can snap to the actual point itself. Tab over.
Click on that.
Maybe try that. So somehow your bridge is
Yeah, I
kinked a
think
little bit.
that may be what's happening too.
So you might not be exactly, just try to snap to the point and see if that works.
With the dimension line.
Yeah.
Yeah, I can snap directly to that, to a point.
Oops, I think my last, my last point here, I should have been bridge width half. I did bridge width.
So when I'm dimensioning, go from the edges to the point instead of a line.
Yeah, see if that works. Okay, so we also created, go ahead and hit save, and you should be able to change your width. Let's go back down to 50 feet. And your whole entire bridge should also consistently go down to 50 feet. Now, one thing that I had in my path design is I actually had a varying width bridge. And to add a little bit of controllability to this, the reason we added in a set of parameters that says I have a bridge width 2 is at one of the midpoints, or some point maybe around the center point of this bridge, I want it to actually expand and have a different width. So once you have a solid, we can start to chop up this into more profiles by using the add profile command under form element. If you just select your solid and click on add profile and then hover over your bridge, you'll see a section curve kind of following wherever your cursor is. And we can go ahead and pick a section of the bridge that we want to add some more parameters to. So actually I'm going to come in here sort of towards the center here, close to the exact midpoint. Doesn't have to be exact, just close. And I'm going to left click, and that will make a profile that now when we select our solid and then select edit profile, we should be able to hover over and click that profile that we just created. So once we do that, we can add in our dimensions again, just like we did on the two ends. And this time I'm going to change the width to my other, I've got a bridge width 2, and this one will still be bridge depth. You could also vary the depth if you felt like you needed to.
It's still not letting me manipulate this guy. I can snap to
Should be bridge width 2 or bridge width 2?
Bridge width 2 half. So now you can actually go into your bridge width 2, and right now they're both equal to 50 feet. And I could change bridge width 2 to 75 feet. And you can start to get your bridge to vary in width along its profile. So if you want to add a little more variation to the bridge as well, that's an option. And obviously the more profiles that you have, the more control you'll have in how it actually changes in width. If you have errors, we're going to have to talk after class. Okay, so does everyone have something at least working? It doesn't matter if your width isn't working exactly. As long as you have a mass that you can change the length and the height, whether the width is consistent or actually works, won't matter too much at this particular time. I'm going to change this all back to, I'll just do 50 feet for now. Now, you've got a bridge path, but you also have to think that we're spanning close to 2,000 feet across a river or across something. We need some way of actually holding it up. And I'm going to go over how we can make this. We can't make this whole thing, obviously, in the time that we have left. But I'm going to get you started. And basically this whole thing is adaptive. It's made up of, and this is just an idea, this beam underneath is a 2-point adaptive component, meaning it can just stretch from one point to the other. And it has a parameter for as far as it stretches, it might change in depth or width. These cables is another adaptive component. And then these rails across the side are another adaptive component. All we need to do, and at this point we could probably, now we can keep that in there. On our 3D, go back into our 3D view. Now that we have this shape, we can start hosting all types of points along this entire curve, the edges and any of the center points, and then offset and create additional splines that we can then use to snap adaptive components to. So what I'm going to do is take the point command, point element, and on this small arc, go ahead and draw, I'm going to snap one point, and I'm snapping to the bottom. I'm going to draw 1, 2, let's just do 4. So I've got 4 points that are snapped and hosted now on that edge of the form element, our solid surface. I'm going to create 4 more points, but each time, let's do this. We need to select those 4 points that we just placed, and we need to turn on the reference planes. Hopefully you can see them. Turn them to always, and then also uncheck the show normal. And now I'm going to take a point element, and I'm going to use a placement plane and hit pick. I want to pick the horizontal reference plane of one of those edge points. And the reason I'm using the horizontal is I want to eventually use this offset to move this point up and down. And we can also turn on the show reference planes on this one as well. If you open up your dialog box for your parameters, under structural, I have a parameter here called cantilever. In the formula, I'm just going to say bridge width let's just do times 0.33. Basically 1/3 of the width. You can do 2/3, whatever you want. Just do 0.33, that's fine. I'm going to take a measurement or strike a dimension. Sorry, before that, use the align command. I forgot to align something. We need to align this plane, vertical plane, and this new point that's kind of floating off into space, its vertical plane, and lock it. Then we can strike a dimension from the perpendicular plane to the point that's hosted on the bridge to its perpendicular plane. And then we should be able to select that dimension and make that equal to the cantilever. Now this point that's hosted on the form element, if you select that point, off to the left you can see the normalized curve parameter. Mine is set to like 0.987 or whatever. We can now move that. I'm going to move this to 1. I didn't like that.
Okay, what are you selected?
Hold on. Somehow I didn't like the lock. So I'm selecting this point that's hosted on the curve and the mass element. Any of these points that are now hosted, we can move them up and down the curve by using that normalized parameter, just like we did with the curtain wall panels. We're going to be using that quite a bit, and basically that's just a scalar item from a number from 0 to 1 that no matter what size this bridge is, that point will always be hosted at that one particular point. And I'm trying to figure out at the moment why, when I try to move it, it doesn't like my alignment. Cool, move on. We're going to go to the next point and we're going to do the same thing. So I'm going to pick the horizontal plane, put a dot off to the side, say show always. Then strike our dimensions. And also make that all of these points will be equal to the cantilever. So for some reason it doesn't like the lock. Like if you try to move the point, it says it has to remove that constraint. But starting out, if you just go ahead and hit the lock, at least so that point will be moving, should be moving relatively close to being aligned. When I say move that point, when you click on this point, you can either change it by the numbers or you could just hover over it and slide it up and down along the curve. Yep.
Your zoom weight, is there a way to like recenter the camera so that when you hold it, it doesn't like flap?
Yeah, so if you select any kind of item, preferably a point, as long as it's selected and then you hit the shift key and start to rotate, it should keep your camera rotating around that point.
You have to have something selected.
Yeah. If you don't have anything selected, it's going to go haywire. So it tries to rotate around the center of whatever you have selected.
Hey Jeremy, what do you do if you keep getting a message, constraints cannot be satisfied? Like, if I try locking it and unlocking it?
For your point,
Yeah.
delete your point and replace it. Make sure you picked that horizontal plane. That's what just happened to me on this one particular point.
Oh, so you had to lock the horizontal, not the, under the verticals?
Right, yeah, don't lock the verticals. And basically what's going to happen is once you've selected all of this, I've got this equal to cantilever. If you move that dot, just tell it to remove the constraints. So I aligned this point, locked it, and then moved the point. Then it says constraints not satisfied. That's okay. And this last point, I want it to actually be kind of close to the end point of that curve. So if you noticed, if you look on the screen, when I move this point, I'm sliding up and down. When I get close to this reference plane, it'll highlight. And I can see that I'll kind of snap to the location of where that point would be located to align with the end point.
Is it okay if your thickness went up top and just having to go underneath it to lock it down?
Yeah, that's all right. You could also just change your depth to negative,
Oh, okay.
and it
Just go
should,
the direction.
yeah, make it go in the other direction. Basically what we're doing, I've got my last point here, is you've just created a parametric offset that's based off of this value called cantilever. So now we can, once you have all those 4 points placed, I need to remove that constraint. You can go ahead and select the 4 outer points and then draw a spline. And we could also, once you draw that spline, go ahead and make that a reference line as well. And you can kind of see that the offset, isn't exact. I get a little bit more space over here towards the middle. Obviously, the more points you add, the more precise your offset's going to be, but we're trying to do everything complex and irregular anyway, so that just kind of helps. I'm going to stop there for now because I know a lot of you guys have your midterm studio projects or it's a pretty hectic week. What I would like you guys to be working on, and if you can, and I know some of you are going out of town and all that kind of stuff, basically on Thursday I'm going to have another file set up. This curve that we've just placed that offsets on a cantilever, We're gonna do the same thing on the outside, but I'm gonna already have that set up for Thursday. But if you guys wanna practice, go ahead and try to set that up. And then we're gonna be making a curve that goes up in the air over this. And then we can start to work, we basically then have our 3 section curves that we can then snap adaptive components to, and then, you know, create that structure that we saw in this other file. Okay? Who is not going to be here on Thursday? You guys? Okay. We will go ahead and we'll, you know, post the video. And then at spring break, we'll talk about more of what's going on over spring break and afterwards. We're closing this project out fairly soon. But basically, this is the last few steps of getting your whole entire bridge to work off of this path. You can also see that on this bridge, I threw in a quick little railing, not pretty or anything, but something to show there. And then we're also going to go over your canopy structures. So right now you kind of have all your elements kind of scattered in separate files. You've been working on your curtain panels. You're now starting to work with your path again to get that parametric and relative. You might want to start to revisit your path. You know, we've already made it where it scales in this direction, but you might want to set it up so it does the slope. Just, you know, constantly try to add some progress to your projects. I know it's a tough week to do that. And just upload something on Thursday so I can take a look at it. We'll go from there. I'll walk around for anyone who had issues.
Jeremy,
Yeah.
I have issues, but I also have a question.
Okay. Well, issues with this class.
Yeah, no, I got it. Thank you.
Excuse me.
Totally just walked into
I
that.
had that no green issue, but it's not a problem of setting, like, it'll work with all the other different things. Like I accidentally put on one of those networks, but when I do cantilever, I have the issue of trace on the side.
So go into your, open up that dialog box. What do you have under cantilever?
I actually raised it because I thought maybe it was too small of a thing, because I had it at .33 that you had. Tried it and it wouldn't do it. And like this is 29, so it's not even that far of a distance, so I'm not really sure.
So it looks like